So Peter said I'm Don. I'm the digital archivist at NYU. And I've only been at NYU for about 3 months now, so we're really just in the process right now of getting the first pieces of what we need to manage born digital collections in place. So I wanted to talk about how the tools and the techniques that we are using to approach all the different aspects of archival processing and management of collections, and how there's new tools and new techniques that we kind of need to develop or adapt to work with born digital collections. Working with born digital records within an archival context has proven to be a challenge on numerous fronts. In essence, all aspects of archival practice, acquisition, appraisal, arrangement, description, preservation, and in particular access, are now being presented with unique problems related to born digital objects. Digital records now arrive in repositories in numerous physical formats. They're transferred through email or shared through cloud storage services and many other ways. The ease in which that we can create and share records with computers can be deceiving, though. Anyone who's tried to recover their own records from more than 15 years ago, say, has probably experienced this firsthand. I probably don't need to stress that there's much work to be done. Archivists are now adapting and developing tools from other disciplines to help approach these emerging problems that digital technologies present to the collecting archival repository. I'd like to speak about several of these: computer forensics, natural language processing, and machine learning, and how they can be applied to archival practice to help us continue to collect, preserve, and provide access to records that are increasingly in born digital forms. Let's first examine some of the obvious problems we face with in collections. Scale. So this is a new collection from Fails. When we imaged some hard drives, we realized that the collection contained over 636,000 files. Scale's interesting. It's not a new problem in archives, but it's different with born digital collections. With a physical collection, we can say measure it with a ruler, or weigh it, I guess. But anyway, you can get a sense of what you would need to store that object over time. With digital, it's not really clear. While you can understand that something is, say, 4 terabytes or 200 megabytes, does that really mean anything? We could also say that you have 1,000 files, and that alone doesn't really mean anything. So, and if you put those two things together, it really doesn't help you that much. Maybe if you know how much you have and the types of files that you have, you might start to get somewhere. But typically, that takes a lot of work to get to. So a single hard drive can easily be handed from a donor to a repository that contains records so numerous that they would dwarf our regular collection. And I think this is a good example of this. We're really kind of surprised how much. This was a single 2 terabyte hard drive that a collection had been, an organization had been storing their records to. From the same collection, we can also look at format diversity, or the heterogeneity of the records pose another problem to deal with. So here we can say that there's 13 different types of Microsoft Word files in the collection, going all the way back to Microsoft Word 4.0 DOS. And in general, we see that there's 27,000 Word documents here. I can assure you that this is not going to be an easy migration process, that we're not just going to put these all through one, workflow tunnel and they'll come out the other side as a modern Word document. No chance. On the other side, we can see all the different types of files that we might find. So graphics, folders, encrypted files, archives, things that are zipped up that have other files, and then multimedia, documents, databases, so on and so forth. Whereas in the traditional workflows and models of dealing digitized content, where you can stress normalization to an understood and manageable format, the realm of born digital archives can be a lot murkier. Basically, you tend to have to find workflows for all these, or make decisions on what you're able to create workflows for. Obsolescence. And I've actually had collections with all these things in it. At NYPL and the World's Fair, 1964 World's Fair records, we did have punch cards that they were used for controlling the waterworks on the fountains. Recently, this is an original Tandy 1000, I think. And in the university archives, we found disks for one of these computers, and it turns out it's really difficult to work with that disk unless you have an old Tandy and an old Tandy drive. We can't even image them, really. So obsolescence, I'm sure everybody's aware of how quick technology changes and how your collection materials quickly become difficult to work with. I guess I wanted to say something about maybe some not so obvious problems working with born digital archives. And so I was in a class that Marvin from Fails was teaching a few weeks ago, where we were discussing what a Google Doc is in relation to the material aspects of what you do. And this is probably about as strange as it gets now, and to kind of see where we are, that a Google Doc, like, nobody knows how it's stored, where it's stored, what it is. When you download it to your computer, you get a choice of things to download. So we're really dealing now with completely dematerialized collection material. So it really, when you think about from the archival standpoint of authenticity or provenance, it really gets crazy really quick. So this is just the next sort of generation of problems, I guess, that we're just beginning to be able to deal with floppy disks from 1995. So the Google Doc should be interesting in the future. Okay, so I'm going to go off script now. Computer forensics. So forensics, you probably all know, is the application of scientific method to ascertain facts about things. So the field of computer forensics is actually really applicable to the field of managing born digital archives, because in the same thing, we're trying to do a lot of the same operations in the end. We want to be able to make valid copies of things. We want to be able to understand things without changing the original. So forensics is a really good model to work with. And I might delve into archive speak here. I apologize if I do. So acquisition, the process of transferring something into a repository. So here I'm showing some tools that we use. On the top, that's a write blocker. Basically, you can see there's a USB and a SATA port, an ID port, and a FireWire port. And the way that it works is that you're able to plug any type of device into the bridge. And the bridge then communicates to the computer in a way that it doesn't allow you to write information. So you're not allowed to modify the substrate of the original, that we're ideally working with a perfectly authentic version of the objects that we're trying to acquire. The bottom, we can see a piece of software. This is called Forensics Toolkit Imager. It's a pretty easy tool. So once you have some kind of write blocker in place, you can usually plug your device into it, and Forensic Toolkit works with all sorts of file systems. So even if your Windows computer won't let you mount an OS X volume locally, FTK Imager will still work with it. So the goal of this is to create a disk image. So you can think about either that you're trying to refresh the media that's coming in so that we don't have to worry about it decaying magnetically further. Or the other thing to think about is that you want to make a fungible copy, so that this new image that you can make when the original hard drive or a floppy disk breaks down and is no longer usable, that can be a replacement for it. It should be as close to perfect as possible, and using forensic method, you should be able to do that. This isn't forensics per se. This actually came out of software preservation. This is another tool that we have at NYU now called the CryoFlux. And what the CryoFlux does is actually allows you to talk with a floppy disk drive and do an analog reformatting of it. So it's not so much concerned with the bytes that are on the floppy disk, but it's actually sampling the magnetism and the voltage. So we're doing preservation at a really low level, at a level that computers don't even necessarily understand, doesn't logically understand. You can't mount the stream image to a computer. You then have to interpret it. That's what these colors are about. So in this case, we can see this is a good capture, orange and green, kind of good sectors. So we have thousands of floppy disks at NYU, or at least over 1,000 that we know of. So this tool is probably going to be very useful in our processing of the collections. Let's see. Okay, accessioning. So using another forensic tool, in this case I'm using a tool called FiWalk, we can document the state of a drive when it comes in. So it's one thing to image it. So we can then use a computer program on it to then kind of turn that into a data set. tell me all the things that we can know about this. So this first page here, you don't need to worry about the particulars, but this is talking about the file system as a whole. Like we can see how big the image is, F-type string, we know that it's a FAT12 file system, so on and so forth. Not the most interesting things, but when we get down in the file object, things get actually really interesting. So here, if we look at a single file, we can see the name of the file, we can see where it is on the disk, we can see the size of that file, we can see if it's allocated, meaning whether it's been thrown away or not. Actually, when we pull in these forensic images, we can see all the thrown away files that people may not have necessarily wanted to transfer. So we can deal with that at a processing level, and we can actually make it so that we don't see those, but they're there. And so on this file, we can see when it was made in 2008 and the last time it was accessed, and when it was created, meaning when it was written to this disk. From the byte runs, we can locate it in the image. So if somebody had some interest in this JPEG, we can pull it out of the image. And we can also go through in things like create MD5 and SHA-1 checksums so that we can document the integrity of the file at the point of accessioning it. Furthermore, we can add plugins, so we can inject our own code into this. So in addition to finding all that file system information on the file, we can go in and tell it to do a file type identification. So in here, I'm using a tool called Fido, which uses another tool called Pronom. Sorry to be going over these tools, but basically we can go in and say, check this file against a database, tell me what type of file it is. In this case, it's a JPEG, but it's a strange, early compressed format. I had to run this by our digital photography expert to figure out what this was, because it made no sense at all. Also, you can see I've done an antivirus check too. So when you're bringing things in, generally if you image something with viruses in it, it's not a huge deal. It's only when you restore those files. And actually, at Yale, we had a collection where a professor was collecting viruses. I don't remember the specifics, but literally had a disk full of different types of viruses from the mid-90s. Okay, appraisal, I'm just gonna, there's lots of tools that you can use once you've acquired an image to do things. So this is a tool called Bulk Extractor. I went through and told it to find me all the telephone numbers in an image. I showed a class at MEAP this and took an image, and then we looked for all the social security numbers and credit card numbers and all the email addresses, and it gets kind of creepy pretty quickly. And then finally, arrangement and description. So this is a tool that we have now at NYU called Forensic Toolkit. It's a full forensic suite done for processing. So we can take those 636,000 files from the fails collection and be able to arrange them in ways, analyze what's there, and try to make an intellectual organization out of a very large collection. So this is kind of contrived. I just made a series called Correspondence and put some years under it, and then you can see the first letter in each one. So this is where we would start making connections to our description, that each one of these bookmarks, sorry, I'm pointing at the screen and then I don't know what I'm doing, but so where it says 1986 or 1987, that would then map over to our description in a finding aid so that this set of files could then be associated with a description. How all that's going to work and how you make those connections, I don't know. It's complicated. FTK is a great tool, but it's designed to be standalone. It's not, when they developed it, they didn't think about how libraries want everything to talk to each other. This is really for somebody making a case to be presented in court. So that's a problem, but this is being used at a number of research institutions and manuscript repositories. The second class of tools that I wanted to talk about were natural language processing, and I should have put machine learning here as well. So once we have these in digital form, there's all sorts of tools out there that researchers are using to kind of take data and turn it into information. So the main ones that I'm looking at or working with are named entity extraction, which is a way of going through and finding names that so names of organizations or names of locations or dates or known quantities. Topic modeling is going through and figuring out in the abstract what topics are being covered in a set of materials using statistical models. Clustering and classification are kind of similar. It's taking groups of documents and finding which ones are similar to each other in different ways. Where clustering is kind of letting the computer do more of the work, classification, you're giving it a set of parameters to work with. Collaborative filtering is kind of letting people interact with sets of files and figuring out what makes sense and recording that. And then language detection, obviously knowing what languages you have in your collection would be important. Okay, so here's a quick case study. This is a project, prototype that I did at NYPL when I was working on the Timothy Leary papers, which they acquired in 2010 and opened last fall. Basically, we processed them with FTK, the tool that we showed you, and we made a description and a finding aid. And then we wanted to see what we could do with those to kind of make those discoverable on a digital level. So what we did is we took the documents, we put them through a migration process. In this case, he was working with a tool called WordStar Pro, which was an early word processor. We had to put them through WordPerfect. That was the only thing that we could find that could handle a WordStar Pro file. And then from there, migrate them through to Word docs. Because our parsing library, which in this case was Apache Tika, really only works with a couple of formats. It's not going to work with a word processing format from 1983. Then we would use the OpenNLP, a natural language processing library, and ultimately store everything in Solr, which is a search index. And then at this indexing phase, we would also combine it with the metadata that we got from our forensic processing. So we would combine this sort of learned information world of things and combine it with the kind of physical reality of the file systems and the files that came off. So how does this all look in the end? We built a really simple web application. And you can kind of see here, if we look, we have the Timothy Leary papers, but then it splits it into the archival files and also the original media items. Since we have all that metadata, we don't force the researcher to work in one way or the other. So if we look at one of these disks, this didn't really work well to make an Access presentation of, PowerPoint presentation of it, so I kind of cut it all together. So if you clicked on one of those disks, you would see a photo of the disk. And then the next thing below it, you would see those named entities. So on this disk, we see that he was writing about Rambo and Ronald Reagan and, you know, all sorts of funny. They're fantastic to look at and this kind of level. But anyway, so we went through, we found personal names, organizational names, locations. Not being an expert in machine learning or being how to train a statistical algorithm, these are pretty much out of the box. We didn't do a lot of tuning on them. So you do get some bad results like, let's find one, Rainbow. I guess that could be a location. Okay. And then it would give you a list of files that were on the disk. So we see the original file names. We can see the archival file if you wanted to go over and see what the intellectual arrangement looked like, the file type, and the dates. And these are the last modification dates, which to me is usually the best date to work with. So it's the last time somebody made a change to a file. And then if we break it down further, we can look at the individual files. Here we can see information that we pulled from the forensic tool, so we know the path, where it was located on the piece of media, the file type, the file size. The language didn't come through in this, but that was part of our textual analysis, and the last modification date. It's always kind of a balance of how much to put here, because do researchers want to know the permissions of files or you know, the mode that it was created with? Probably not. So it's pretty simple here. And then on the bottom, you can see we have all the named entities that were pulled out of that file. And it was all hyperlinked through so that if you clicked on one of those, it would then perform a search against that name in the index. So here, is that legible? Oh, this looks really bad. Sorry. Here, like I clicked on a file for Richard Alpert, and it pulled up 34 different files in the Leary papers that had Richard Alpert in them. So here's one example, and you get a big list. Wasn't the best interface, but it kind of worked. There was a lot of scrolling and going through. So the problems. Tika's file type support is pretty minimal. It really is used for modern records, so it ended up making us have to create really difficult migration paths. Proprietary file compression. This was a weird one. Towards the end of his life, Larry was working with Microsoft Word on a Mac, and if you did a file type identification of those, it would always tell you that this is a Word file. The header would be there and everything, but he was using a program that then compressed them to save space on your disk. This is when you had, like, you know, a 20 megabyte hard drive. So to figure that out, there was no evidence of it. We just had all these files that didn't work. Luckily, another staff member who's at NYPL was able to crack the code one day and figured out it was this sort of disk doubler compression. Anyway, that took months to figure out. And then the named entity extraction results, again, it's really complicated, difficult stuff to do. So the improvements, if we were to build something like this again, we obviously need a better infrastructure. This website crashed constantly. Somebody gave out a link at an essay workshop to it to try it out, and it crashed within 3 minutes. So I'm not a web developer. Probably need real technologists working on that. Distributed processing, machine learning. Distributed processing, this stuff takes a long time to work. A single disk could take hours to go through each file and pull out the entity extraction. So there are frameworks in place to allow you to be more efficient about how you're doing it, as long as you have enough computers to do so. Automated clustering and topic modeling, I kind of mentioned those earlier on. Those were the next things that I really wanted to implement, so that if you were interested in this file, here's some other things that might be similar that you might not have found in any other way. Integration with discovery interfaces, authorities, and access systems, we didn't do any of that. I can only imagine how complicated it'll be. And then finally, having some sort of linked open data interface on top of it, because essentially when we look at this stuff at this level, it is really a data set, and I don't see a real reason why we wouldn't be able to share it. So, Born Digital Records at NYU. This is our workstation that we just got set up. That device to the left with the floppy drives, that's the CryoFlux. And you can kind of see the right blocker in there, and then I did the easy visualizer from FTK that always looks like you're doing something really fancy. But in reality, we don't really use the visualizer that much. It looks nice, though. So the way that we're approaching things at NYU is that we have a pool of different types of records that we need to consider right now as what we're collecting and what we need to make available and what we need to preserve. So the first part of this is the media-based records, kind of the old stuff, strange SideQuest cartridges and zip disks and 8-inch floppies. So we kind of had the methodology to work with those, kind of like all the stuff that we went through in the Leary of imaging things and being able to arrange those images. A second area now that we're kind of thinking about are media-free records, so that it's probably becoming more and more unlikely that a donor is going to transfer material on a piece of gear, a USB drive or whatever. That in the future we really need to figure out how people can transfer things into NYU without the physical part of that. So we're looking at a couple different systems. This is just getting started. It's probably going to be a big project, and there's not that much work that's been out there on how to do this for an archival repository. So this is one application we've been testing. Oh, that should say email. I'm sorry. I missed that. So for email, we're working on a project called ePads collaboratively with Stanford, Columbia University, the Smithsonian, and the Bodleian, which is to do a lot of these things that we just looked at for these media-based collections, but to do it with an email account directly. So in this case, I pulled in my personal email account, and you can see this fascinating email that I was able to uncover with it. But anyway, again, this is designed to work at scale, so we can take in a really big email collection, appraise it, find out what are the privacy issues that we need to be concerned with, figure out which parts we need to transfer into a repository or which parts are just not going to become part of the collection. It's a two-year project. I always forget whether it's 2 years or 3 years, but it's slated to finish next fall of 2015. Web archiving, NYU supports two different tools for web archiving. So this is the Archivist, which is the Internet Archives tool, and we're also working with the California Digital Library's web archiving service. So again, this is another kind of big pool of information that we're collecting that right now lives on these services servers. Eventually, we want to bring this stuff into our collection and be able to work with it like we would any of our other collection material. Okay, social media feeds for the second time. This is a tool called the Social Feed Manager, which is being developed out of George Washington University, which we've been using. And it's the first phase of the project is how does an archive collect Twitter. So we can do this with web archiving, which would grab the front end of things. But with this tool, we're actually able to go in and work with the Twitter API and collect a data set that gets stored in a server in JSON format, and then gives you a kind of interface that the person working on collecting can work with. We're hoping probably this month that we're going to do a set of exports to CSVs for these Twitter accounts that this is the tenant that's using this. But again, we haven't really done too much planning other than turning it on, adding some Twitter accounts, and let's see it go. So I checked today, we had 16,000 tweets in it for these six accounts. So yeah, scale again becomes an issue. All these things that we're working with, we have the same sort of set of fundamental problems that we need to address with, and that's how are we going to make these discoverable? How are we going to make these accessible? And how are we going to preserve these items? So we're trying to use all these different tools, but in the end, not think of them as siloed things, that there needs to be an underlying platform or an underlying architecture in which we can deal with all these materials and make them ultimately accessible and preserve them. So that's it, I guess. Thanks.